Hi, my name is Vincent, and today I want to take a look at adding and subtracting complex numbers. So take a moment to read this definition for complex numbers. And the form of a complex number is an a plus bi form, we call it, where a and b are real numbers. Now this is more easily understood if you look at an actual example of a complex number. So 2 plus 3i, the way you should think about these is treat them almost as a pair of coordinates. Let's say in this case the real part is 2 and the imaginary part is 3. So if we look at it this way, then when we plot this on the xy axis, so we're looking at, let's say this is 2 units to the right and this is going 3 units up. All right, and we call this horizontal axis the real axis and the vertical the imaginary axis. So 2, 3, instead of just thinking as this as plotting a point, imagine you're connecting the origin to the point 2, 3. So a complex number is really just a number with direction. Now they behave a little different when we want to add or subtract complex numbers together. The way we do it is if we look at two complex numbers here, when we add them or subtract them together, we add the real components together. The real components are the terms without the imaginary I. And then we add the imaginary components. So in this case, it would be terms B and terms D because they both have the I or the imaginary component. This is more easily understood, though, with actual examples. So that's what we'll do next. So in this situation here, we have two questions. We want to simplify the expressions to a plus bi form. The first thing I would recommend doing is just expanding these. And what I mean by that is we have negative 3 minus 8i. But then when we distribute this negative here, when we're subtracting, it's kind of like subtracting polynomials. We're going to have plus 1 plus 9i. But then for this part, we have to be careful. Make sure when you do simplify that you are combining the real parts and you're combining the imaginary parts. So when we write out our final answer, we have to make sure that we're doing negative 3 plus 1, which is negative 2, and we have negative 8i plus 9i is plus 1i, or just plus I. So this would be the solution to question 1. Now for question 2, same thing. I would expand this first. So we have 9 plus 10i, that we could just write. And now when we distribute this negative, we're going to have plus 2 and now minus 3i. So then to simplify all this, once again, we're going to add the real parts. Those are the parts without the i's attached. And we're going to have 11 for the sum of the real numbers. And now for the imaginary components, we have 10i minus 3i. So this will simplify to plus 7i. Now this whole process could just seem kind of, like a rote memorization technique. So the last thing I want to do before we end this video is look at the basic concept of like what adding complex numbers actually is. So if we follow the same steps as before, when we add the real parts, 6 plus 2 is 8. Negative 3i plus 5i is plus 2i. But to explore this just a little bit more, this red line here is modeling the first complex number, 6 minus 3i. So this is modeling the first one. And the one in blue is modeling 2 plus 5i. But as it turns out, complex numbers behave exactly like vectors. So if I want to add them together, it's the same way I would add two vectors together. So if you don't know how to add two vectors together, the short version is of this, it's called the head-to-tail method, is that I would place the tail of this vector. So if I move this, the tail is the beginning, and the head is where the arrow is. So when we add vectors by the head-to-tail method, we place the tail of one vector by the head of the other vector. And then the resultant, when I add those two, would be the final location where I land. And then to add them, the final step is I draw a line from the origin to where those two vectors head to tail wound up. And in this case, if we mark this location, we could see that the location, if we write the coordinates down, I'm going 8 units to the right, and I'm going 2 units up. Now, this method also works if I were to add it the other way around. So if I had started off here with the vector 2, 5, and I were to add the vector 6, negative 3 to it, you see how if I use the head to tail method, it's going to land me at the same location. So this is just a little bit of an extension to understand the concept of this stuff. And one final thing here too, the calculator, the TI series, can add complex numbers together. So if you were to go to mode and switch from real to a plus bi form, that's switching it to complex form, you could just type in this entire expression. So we have 6 minus 3, and the I is second decimal. See, it has like that blue I attached there. And if we write in the other complex number, we have plus 2 plus 5i. And we work this out, you see how it's going to work out for us 8 plus 2i. So this is just another way of evaluating complex numbers using technology. Okay, well, this is going to conclude this video on complex numbers. If you found this video helpful, please click like and subscribe below, and thank you for watching.